where those values are. I know we defined them. The quadrantals are basically the axes, or angles that land on the axis. Okay? And as you look at the angles that land on the different axes, whether the x-axis, y-axis, whatever, they're always going to be multiples of 90 degrees, or pi over 2. Okay? Now, as you go around here, you get 0, bless you.
How big is this guy going to be like? Are we trying to laugh?
I don't know. So, as we go through a lot of this stuff here, we have to figure out what values we're going to give certain things. When I'm looking at 0, 0 is always to the right. Everybody okay with that? So 0 degrees or 0 radians would be here. As I rotate up, I'm at pi over 2. This doesn't even want to write anymore. Pi over 2. Here's pi, 3 pi over 2, and then back around at 2 pi. Everybody okay with that? Just rotating around. I'm leaving it in terms of pi. I want to start using radians a lot more than I am degrees, just because kind of how things are going to start working more and more. Now, what is my value of y when I'm on the x-axis? 0. What's the value of x when you're on the y-axis? 0. So I know that no matter what, the ordered pair here is going to be something, comma, 0. Over here it'll be something, comma, 0. Here it's 0, comma, something, and here it's 0, comma, something. Everybody okay with that? Now, the other portion of that we got to figure out what to call it. So when we deal with the unit circle, we're going to get into more of that today. We have to give it a unit. So we just give it a unit of 1. We call the radius 1. So this value from here to here is 1. If I go to the right one, then I go up 1, left 1, down 1. So vertical, my y value would be positive 1. Oops. Okay. Going to the left at pi would be negative 1. And then down would be at 0, negative 1. Everybody with me so far?
Yes.
Okay. So here's what's happening. As you get into this, you start at 0, you work your way up, work your way down, and you work your way back around. So as you're going around the circle, your degrees or your angle changes as you go around, which means your values change as well. What comes first in the alphabet, x or y? X. What comes first in the alphabet, sine or cosine? Cosine. So if I wanted to figure out what my r value is here, do I have an x and a y value to solve for that? Yeah. What's 1 squared? 1. What's 0 squared? 0. What's 0 plus 1? 1. What's the square root of 1? 1. What's my radius? 1. 1. You know what convenient that is? Go around the circle then. What is your cosine at 0? What comes first in the alphabet, x or y? What comes first in the alphabet, cosine or sine? Cosine. What's your cosine at 0? 1. What's 1 divided by 1? 1. What's your cosine at 0? 1. What's your cosine at pi over 2? 0. What's your cosine at pi? 1. Negative 1. What's your cosine at 3 pi over 2? Negative 0. And back at 2 pi, you're at 1. Okay. Sine. What's your sine at 0? 0. Sine at pi over 2? 0. Back to 0. It rotates and oscillates itself around. Okay. You probably might vaguely remember when I did this. If I start at 0 and I end at 2 pi, what's halfway between? 1 pi. What's halfway between 0 and 1? Yes, sir.
I was just going to ask what about tangent?
Getting there. Okay. Tangent works the same then. I'll show you that. Now, as we went through all of that, did the sine or the cosine value ever get larger than 1? No, it was always bounded by the radius of 1, wasn't it? Okay? So the sine and the cosine value never get larger or smaller than 1 or negative 1. Cosine. When cosine starts at 0, what was the x-coordinate at cosine? It was 1. What was it at pi over 2? 0. At pi was negative 1. 3 pi over 2 is 0. And 2 pi goes back up to 1. It starts over again, doesn't it? Those are the quadrantals for cosine. It creates its own curve. Okay? Think about the sine. If I did sine starts at 0 when it's 0. As it starts at 0, when it goes to pi over 2, what does it become? 1. It goes to 1. It goes back to 0. It drops to negative 1. It goes back to 0. Sine is the same thing. It's just shifted, isn't it? Yeah. They're pi over 2 shifted of one another. Okay? Now, you were talking about tangent a second ago.
Yep.
If you think about what we did with tangent. So, tangent values, we know it was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Tangent is y over x, isn't it? So, what's 0 divided by 1? 0. What's 1 divided by 0?
Undefined.
Undefined. What's 0 divided by negative 1?
0. Undefined.
How do you graph undefined? Do you remember?
It creates
Asymptotes. Okay? So, at tangent has asymptotes at pi over 2, negative 3 pi, or pi over 2 and 3 pi over 2. What was tangent at 0? 0. Asymptote. What's tangent at pi? 0. Asymptote and back to 0. Now, tangent's the oddball. Tangent, we can figure out something to them. Tangent, you can do that. As you start thinking about your triangles that we have, or our other angles, we had pi over 6, pi over 4, and pi over 3. You okay with that? Those three angles were derived from just two different triangles, 30, 60, 90, and a 45, 45, 90. You okay with that? Now, if tangent is, excuse me, if tangent's going to be y over x, that means it's opposite over adjacent, isn't it? So if it's opposite over adjacent, which of the two triangles, the 30, 60s or the 45s, has an opposite and adjacent that's the same? 45. At 45 degrees, no matter what the values were, it's one side versus the other. They're always the same. So what's the same? If you have the same number divided by itself, what's it always going to be? At 1. Okay. So do you agree that pi over 4 is halfway between pi over 2 and 0?
Yeah.
So here it's 1. Do you also agree somewhere between pi over 2 and pi is 3 pi over 4? Okay. Now, if I go 3 pi over 4, what quadrant do I go to? I go to the second quadrant. Over here, the signs, SIGNs, for the x's and y's change, don't they? X becomes negative, y becomes positive. So over here, tangent, is it going to be positive or negative? It's negative. It's negative 1. In the third quadrant, then, it becomes positive 1. And then in the fourth quadrant, it goes back to being negative 1. So tangent's this weird ball. It goes up through here. Let's make the dot bigger.
It's fun.
Okay? Tangent isn't continuous because it's got asymptotes. It's got asymptotes at a certain rate, within a certain range value. Okay. Now, not range, excuse me, certain domain. All right. Now, obviously, I'm not worrying so much yet about how we do go about grafting all these things. The reason why I like to show this is because how the quadrantals form everything that we do. Yes, sir.
Was the blue line sine?
Blue line was cosine. I started with cosine. I went blue, cosine was blue, sine was, and in all honesty, for right now, it's not that big of a deal if you can't recognize which one's which. We'll get to do all of this stuff eventually, okay? Now, as you go back, you start thinking again about the other trig functions. Secant and cosine are just reciprocals of one another, aren't they?
Yeah.
Right? So, what's the reciprocal of 1? 1. It's not an opposite reciprocal, it's 1. What's the reciprocal of 0?
Undefined.
Undefined. It's an asymptote. What's the reciprocal of -1? -1. What's the reciprocal of 0? Undefined. It's an asymptote. And they're back at 1. Do you agree? Somewhere between 0 and 1 in the range is 1/2?
Yeah.
What's the reciprocal of 1/2? 2. So if this was half here, this means it'd be 2 here. It blows up. That's this. Reciprocal functions just blow out versus moving it, being continuous. Again, this is stuff that we'll get to, but that's why all these reciprocal things work. Okay? So the idea here is that these quadrantals, 0, pi over 2, pi, 3 pi over 2, and 2 pi, those angles going around the circle are kind of important because they allows you to plot everything as you get into it. Now, if I wanted to list then all my trig functions of 270 degrees, I'll go back to a degree one. 270 is where? 3/4 of the way, okay? It's down here. What's my ordered pair there?
That's 0, -1.
0, -1. So my ordered pair is 0, -1. So as I go to write out my 6 trig functions, cosine at 270 is 0. Sine at 270 is tangent will be what? Undefined. Y over x, it's undefined. Okay? Reciprocal functions. Secant at 270. What's the reciprocal of 0? Undefined. What's the reciprocal of -1? -1. It's not opposite reciprocal. It's just reciprocal. And what's the reciprocal of undefined? 0. Again, I'm doing that just off the ordered pair as opposed to writing it all out. If I did cosine at 270, it's still x over r. It's x over r, which is 0 over 1. This was -1 over 1. This was -1 over 0. You just don't write it like that. You write it as undefined or 0. Okay? Does that make a little bit of sense?
Yes.
Once you get used to the idea that it's not an opposite reciprocal, then you guys wind up being okay with it. But a lot of times people always forget because you're so used to slopes and stuff. You want to do opposite reciprocal. Okay? Don't do that. Good times, huh?
Yes.
Very good times. What's that? What are the 6 trig functions at 3 pi over 4? Or 3 pi over 2, whatever it might be. It could be a positive, it could be a negative, it could be any one of those as we go around. Alright? Which now lets us to be able to show why all this stuff actually works.
Murphy, I've got a question.
Yes, sir.
-3 pi over 2 would be on the bottom or on the top?
Yeah, the top. As you're going.
That way.
Yep.
Guys, we gotta look at
Oh, weren't you? It's because he
Just a little bit. Get a little tacky. Now, what I want to do here. Why does all this work? Yes, ma'am. What do you mean? This, what'll happen is, because when you're on, you just basically figure out what quadrantal are you on. So instead of evaluating the trig functions at, you know how we did one where we had with the ordered pair, then you found the radius and did all that kind of stuff? Here, we're going to start getting into, what do you do at the angle? So when you're on a quadrantal, remember it doesn't have a reference angle? Because you are on the quadrantal, that's why I was doing those. Whereas if I ask you 11 pi over 6, where is that? Exactly. Do you know how to find 11 pi over 6?
Yes.
What's the reference angle for 11 pi over 6?
What you said.
Yeah, pi over 6. And what quadrant does it go to? It goes to the fourth quadrant, okay? So then the idea here is it. Yeah, those always, yeah, that's where we're starting with that. Now, what I want you guys to look at, what I gave you was called a unit circle. And I'm going to start by asking you to label your ordered pairs for your quadrantals. The quadrantals, 0, pi over 2, 3 pi, 3 pi over 2, and so. So we have 0, pi over 2, pi, 3 pi over 2, and we come back up to 2 pi. What was the ordered pair at 0? It was 1, 0, wasn't it? Okay. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Just did that, just rewrite it out, putting it on the sheet. Okay. From that, we have to think and remember, how do you get 30-degree angles and 60-degree angles and 45-degree angles? We used what? Special right triangles, didn't we? So if you have a special right triangle, this would be our first angle, would be at, bless you, it would be at pi over 6. You be okay with that? Up 30 degrees, pi over 6. Now, if theta is there, because that's my reference, in a 30, 60, 90 triangle, what does the 30 look at? What are the ratio of the sides? Remember that? It's a small size. Which one was that? Well, yeah, the opposite of 30 is yes. What?
The one that's.
Yeah, 1 times. Okay, that's what I was getting at. So this was a 1. This across from the 60 was the root 3, and across from the 90. Sorry. I know. I was thinking 2 across here. Thanks. All right. Does that vaguely ring a bell? Mm-hmm. You guys voted as x, x root 3, and 2x. Or you might use q's or however you did it before. For us, for what I'm going to do is I'm just use the numbers. The numbers won't change. Okay. So if I'm at 30 degrees, what's my cosine? What's my adjacent? Root 3 over 2. What comes first in the alphabet? Cosine or sine? Comes first in the alphabet, x or y. What's my x-coordinate at that point? My x-coordinate here is root 3 over 2. Okay? If you think about it, if you place theta, and you drew in your right triangle, if this was 30 degrees, that means the root 3 is your adjacent. The 2 is your hypotenuse. What is your opposite? It's the 1. So what's your sine at 30? 1/2. Okay. What's your cosine at 60?
Couldn't tell you.
What's your adjacent at 60? 1. What's your hypotenuse? 2. So what's your cosine? 1/2. So 60 degrees is pi over 3. So it's 1/2. And what's your sine at 60? Root 3 over 2. Okay. That leaves me one other triangle that I have to draw, doesn't it? 45. 45 in terms of radians is what? Not pi over 90. Isn't it halfway between 90 and 0? What's halfway between 45? So what's half of a half? A fourth. So it's pi over 4. So if you have 45, 45, 90, wasn't that 1, 1 at a root 2? Don't they have the same sign in the cosine? Because it's opposite over hypotenuse and adjacent over hypotenuse. If the opposite and adjacents are the same, that means their ordered pairs are going to be the same. So what's cosine? Root 2 over 2. So at pi over 4, it's root 2 over 2 and root 2 over 2. Okay? Now I haven't done tangent yet, but we will. All right? Another trig function. That's just y over x. Excuse me. So from here, what changes to the second quadrant? Doesn't this theta here and this theta here, don't they have the same reference angle? Remember, this point then just gets reflected. When it switches over to there, what sign SIGN changes? The x coordinate. So what's your cosine at, what is it? 5 pi over 6. Yep. At negative, I'm sorry, not negative, excuse me. At 5 pi over 6, it's negative root 3 over 2, comma 1/2. What's going to happen at 7 pi over 6? They both become negative, don't they? Yeah. And, okay. Go back to what we did the other day. We know that in the first quadrant, they're both positive. In second quadrant, it's negative, positive. Third quadrant, negative, negative. Fourth quadrant, positive, negative. Think about the next bit. Where's tangent going to be positive? Which one? 1 and 3. At 1 and 3, they're both, tangent's going to be positive because the signs, SIGN, are the same. Positive divided by positive, y over x. Tangent's positive. Negative divided by negative is, that's why tangent is positive. Okay. Tangent's negative, second, and fourth. Okay. The positive and negative signs don't change with the reciprocal functions. So if cosine's positive, secant's positive. Because it's not opposite reciprocal, it's just reciprocal. Okay? Sines and cosecants always have the same signs, SIGN, whatever quadrant they're in. They're the same thing with tangents and cotangents. If it's positive, then the reciprocal function is positive. Right? Those things always hold true. So what I'm getting at here is, on the unit circle, which is what you guys are looking at here, there is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, basically 17 angles as you go all around, because I'm double counting with 0, 2 pi. Okay? Within those parts, each one of those has an ordered pair. There's only 3 different ordered pairs, aside from the quadrantals. They just reflect the move. What I'm getting at is, if you know first quadrant, better yet, if you can even just draw your 2 triangles, you can answer any question that I ask you. If I say, what is the sine at negative 4 pi over 3? What would I do first? Plot it, draw it. I would plot it, I would draw it. Negative 4/3 pi means I start at 0 and I go negative. I'm beyond 1 pi and I come up. How much? A third. What's my reference angle? Pi over 3. Which angle is pi over 3, a 30 or a 60? It's a 60. It's a 60-degree angle. What's opposite the 60? A root 3. What's it next to the 60? A 1. In this case, I had to move it left 1. It's negative. And 2. Sine is opposite over hypotenuse. What's the sine at negative 4 pi over 3? Root 3 over 2. That's how this works. If you know your two triangles and you know what's opposite you all the time, you're going to be fine. You just got to draw it. It's quick. That's why I did all those reference angles over and over and over again. So you can spin it, figure out where you're at, and know which one you're working with. Okay? Yes, sir.
How do you get the size?
What's across from the 36? You have to know your size of the 30, 60, 90 triangle and 45, 45, 90. And then just what quadrant are you in as far as what sign, S-I-G-N, you have to deal with. Yes, sir. No. Remember, your two triangles, when you have your 30, 60, 90, across from the 30 is always the value of 1, across from the 60 is always the value of root 3, and here is always the 2. No matter where this is placed, that always holds true. It don't matter. Across from the 60 is always root 3, okay? So as you place it in here, you just have to remember, is it positive? Does that make sense? All right.
I have a question.
Yes, sir. Yeah.
How do you find the points of like pi over 6? Like, how do you find that point?
Pi over 6, it's up 30 degrees.
Yeah.
So don't you need ordered pairs we were talking about?
Yeah.
Okay. What comes first in the alphabet, sine or cosine? Cosine. What comes first in the alphabet, x or y? X. What's cosine of 30? Yep. What's cosine of 30? So again, think about the cosine of 30. Go back to knowing what quadrant you wound up in. If I'm at cosine of 30, it's adjacent over hypotenuse, root 3 over 2. Sine of it been 1/2, so your x is root 3 over 2. Sine is 1/2. That ordered pair then when it goes to this quadrant, the second quadrant, the only thing that changes is that it went to the left, which means your adjacent value goes negative, your x goes negative. When it reflects down, they're both negative, and when it rolls back, it just becomes the x value is positive. That's why, as long as you know how to draw a 30-60 or a 45-45-90 triangle, you can place any one of these parts because you know how to get reference angles. That's why you don't need to know the entire unit circle like the back of your hand. If you know first quadrant, everything is reflects. Everything reflects. Let's try it out here. So let's do 7 pi over 4. If I do sine, oh, we just did sine. Let's do cosine. Cosine of 7 pi over 4. First thing we got to figure out, what quadrant does it go to? Fourth quadrant, very good. So we know we have to go fourth quadrant. Oops. Oops, I don't want to draw that. My reference angle is pi over 2. I'm sorry, pi over 4, excuse me. So 45, 45, 90. That means my adjacent is 1, my opposite is negative 1, my hypotenuse is the root 2. Cosine is adjacent over hypotenuse. What's cosine of 7 pi over 4? 1 over root 2, but we write it as root 2 over 2. Yes, ma'am.
Could you touch vertical and
No, never do that. Never worry about it. You shouldn't. I want you to get the habit of understanding, without rewriting it. Just understand that pi over 4 is 45. Okay, those reference angles like that, you should know just those quick back checks like that. There's only going to be 3 of them. Your reference angles are only going to be pi over 6, pi over 3, or pi over 4. Otherwise, you're on a quadrant. That's the thing, guys. There's only 3 reference angles. There's only 3 of them. Okay. Let's do secant 11 pi over 6. Oh, we just did one that corner. Let's do, let's do 4 pi over 3. Secant 4 pi over 3. All right. Secant 4 pi over 3 puts me into what quadrant? It's positive, so we go around.
Third quadrant.
Third quadrant, okay. So we draw it, come around, gives you a reference angle of pi over 3. Okay, you're past that. Pi over 3 is your 60. What's opposite your 60? It's the root 3, but it moved down, so it's got to be negative root 3. Adjacent to it is a negative 1. Hypotenuse is a 2. Secant is the reciprocal of what? Cosine. Okay. Secant is the reciprocal of cosine. So what's the cosine at here? Cosine would be a negative 1/2. So the secant would be negative 2. Okay. Cosine there is negative 1/2, which means secant's the reciprocal. Just flip it. Okay. Remember a second ago when I drew the cosine curve? The cosine curve blew up. This is where it blew up. This goes through. Remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 total spots that they could land, aside from quadrantals. Add the quadrantals in, it means there's 16. Okay. Of those 16, 3 of them basically repeat and change signs, IGNs. Okay. There's only so many possible questions of this. All right. There really is. There's a finite number of these problems that you can do. Yes, sir.
So you're not going to give us anything like, I don't know, like 57 degrees?
No, can't. Not without using a calculator. Okay. There will be a time. What's half of 30 degrees? 15. So what's half of, was it pi over 6? What's half of pi over 6? Pi over 12. There will be special angles at pi over 12, and then at 75 degrees. So that would be what?
Will there be one between every single?
No. There's only 2 other real kind of fancy ones. Those are when you do what's called half angle and double angle formulas. That's pretty tough stuff. I gotta skip something for that to show you. Yes, sir. Yes. Yeah. Like I said, you don't have to worry about that though. You might remember this from last year. If you ever did like a square, if you have to do like a square or a sine or a cosine, if you did sine of 75 degrees by mistake or you got that, you probably got those weird roots every once in a while, where you write it up as this huge long formula, like root 6 plus root 2 all over 4. There's reasons for that. It's a special formula. Again, I gotta leave something for pre-calc to show you guys. Okay. Let's do a tangent. Let's not do cotangent. Cotangent negative 3 pi over 4. Cotangent negative 3 pi over 4. Okay. Cotangent is reciprocal function of tangent. And then 3 pi over 4 negative, you just spin the other direction. 3 pi over 4 is almost the full pi, but it stops short, which means I'm in the third quadrant. Reference angle is pi over 4, which means my opposite, my adjacent are both negative 1. Cotangent is reciprocal of tangent, isn't it? What's tangent there? 1. So what's cotangent? 1. Getting like worrisome looks. You guys are like, wait, what? Is that all there is?
I don't think any of us are very sure of it.
That's all there is to this.
See that with every section.
But this
I
one,
don't take that as like to heart because it's like every section is easy and that's all there is to it on every.
with this one, it really is. That's when you get down to this. If you know how to draw those 2 different triangles, and you know how to plot them in the first where signs and stuff are positive or negative, that's all you have to worry about. I know you guys can do reference angles. That's why we've been doing them nonstop for the past a week or so. That's the whole reason why I push reference angles so hard with you guys in the beginning. So that when you have to actually use them, they're like, okay. But yeah, you're right. Most people are like, so Mrs. Murphy, he's going to do something weird here. No, not really. You can, but not yet. All right. Let's see. I don't think I had. Did you want to do another quadrantal or anything?
We already, it's just
Or pairs? Which one?
You do cosine.
Cosine of what?
I mean, I'm still confused, like, how you do cosine.
Okay. When you first learn 30, 60, 90 triangles, you guys learned them from an equilateral triangle. You agree? So equilateral triangle, all your sides were the same. All of your angles were 60s. Okay? When you drew the perpendicular bisector, it came 30 here and a 90 there. Okay? Now, what we always did was, if I call this side 2, that means this side is 2, and this guy, they bisect, both become 1s. You okay with that? Okay. So this is 1 squared plus something squared is 2 squared. What's 1 squared? What's 2 squared? What's 4 minus 1? What's the square root of 3? Square root of 3. That's where you got this root 3 from. That pattern never changed. So whenever you have a 30-degree angle, always opposite you was a value of 1. Always adjacent to you was the root 3. Always the hypotenuse was 2. That never changed. Same idea with the 60. Opposite the 60 was always a root 3. Opposite, adjacent to it was always a 1. So whenever you go plotting something like cosine, we go, 11 pi over 6. I do 11 pi over 6. 11 pi over 6 is almost 2 pi, right? So I'm all the way over here, coming around. Gives me a reference angle, pi over 6. You okay with that? So pi over 6 is a 30-degree angle. What's always opposite a 30-degree angle? 1. What's always next to a 30-degree angle? The root 3. Hypotenuse is always 2. The opposite here just happens to be a negative because it has to move down. Because the y value there is negative. Okay? So as far as the cosine is, the cosine here is, is your adjacent over hypotenuse. Your adjacent is the root 3. Your hypotenuse is 2. It's positive because the root 3 is positive. The 2 will always be positive because you had to find that by taking the square root. And whenever you did the square root, you had to square all your values. That's why you had, negative 1 squared is 1. Okay? That's where that root 3 comes into play. Okay? Is that a little bit clearer? All right? What do you mean? If it's a 30, 60, 90, those are always the sides. The signs, SIGN, might change as far as what quadrant they're in, but yeah. That's 45, 45, 90. There's only 2 triangles. There's only 3 different angles. There's only 3 different reference angles. Yes, sir. Okay. Oh, and radians? 240, so that's 60 degrees off to here, so that's 4 pi over 3. What I want you guys to do today, I think I already posted it on the calendar. I want you to do 34 through 36. Those are the 6. You're doing the 6 trig functions on quadrantals. And then, and then 45 through 60. Okay? Those are just all reference angles. What's the cosine at 315? What is the cosine at negative 210? So on and so on. Spin it, draw your triangle, get your cosine, get your sine, all that. All right? Get your reference angle and work off. So what did I say, 34, 36? And then 45 through 60.
You know what the age of those are?
788, 789.
Where's it, 45 through 60 all?
Yes, sir. Yep. I want you guys to practice this stuff. Because then eventually you start working backwards. And you work backwards, there's only so many triangles, there's only so many angles. And it just matters where are you positive and negative and how do you place it. There are rules to finding these things. Yes, sir.